Example 1, solve the system x plus 2y plus z equals 4, 2x minus y minus z equals 0, and 2x minus 2y plus z equals 1. When you see a system of 3 equations with 3 variables, your first priority should be to make a system of 2 equations with 2 variables. You want to simplify it down from what it is to something simpler. And the system of 2 equations with 2 variables, before we did it, we did a substitution technique because one of the equations was really easy, like z equals 2x or something like that. Now if I want to get z is going to equal 1 minus 2x plus 2y. This would be z equals 2x minus y, or z equals 4 minus x minus 2y. Any one of those is going to be a rather large substitution. Again, I'll show you that in a minute anyway, but for this one here specifically, elimination is a little bit easier. If you choose to eliminate, what you want to do is you want to pick 2 equations and get rid of a single letter, and take another 2 equations, get rid of the same letter. So if I pick the top and the middle and get rid of z, and I pick the middle and the bottom and get rid of z. Okay? It's not good to get rid of z and then get rid of x. Get rid of whatever you get rid of the same thing twice. But 2 different pairs. The other pair option would be the top and the bottom, and we can get rid of the z also there. But looking at it, z minus z, z minus z, it cancels really easily, right? So if I take the top 2 equations, add them together in their current state, z and negative z are going to cancel. I get x plus 2x makes 3x. 2y minus 1y is equal to plus 1y. Z minus z cancels, equals 4 plus 0, which is 4. If I add the middle equation to the bottom equation, 2x plus 2x makes 4x. Negative 1y, negative 2y make negative 3y. Negative z plus z cancels, and 0 plus 1 makes 1. And just like that, by a double elimination, eliminating z twice in 2 different pairs, I create myself an xy system. This has the answers to x and y embedded in it, and then once I know what x and y equal, I can come back over here and figure out what z equals. All right? So get rid of a letter, get rid of the same letter again, and then solve the system that's left over. Now, one thing that happens on these problems, and I alluded to that last time we saw these when they were a little bit simpler, is they get to be a lot of work. And you got that little tiny homework box there to do all the work in. So a couple, they're not really cutting corners, but just cutting some work out of your thing that I think you guys can all handle. All right? Would everybody agree that getting rid of y is easier than x here? Because 3 times that, and that makes negative 3y, right? So what I'm going to do here is this. I'm going to multiply this by 3. But instead of writing 9x plus 3y equals 12, here, what I'm going to do is I'm going to multiply and add at the same time. And again, I think you guys can all handle this. If you can't, then by all means, do what you have to do. But if I do 3 times 3x is 9x, that adds to the 4x to make a 13x. 3 times y is 3y minus 3y cancels. 3 times 4 is 12 plus 1 is 13. That is legal. I'm doing everything I'm supposed to do. I'm just not writing down the step where I actually create this new expression. All right? 9x plus 4x, 3y minus 3y, 12 plus 1. And if 13x equals 13, that means x equals 1. Once I know that x equals 1, I go back to any equation that has x and y in it. If I go over here, it's too many letters still, right? If I go back either to the red equation or the green equation, I'm going to go to the red. 3x, that would be 3 times 1, plus y is equal to 4. If I move the 3 to the other side, that gets me y equals 1. And now that I know both x and y, I can go back to any one of these 3 equations. Which one do you guys want to go back to? The top one, fine. Okay, so x and y are both known. They're both 1, and z is what we don't know. So x equals 1 plus 2 times 1 for y. 2y is 1 times 2 is 2 plus z equals 4. That makes a total of 3 plus z equals 4. Move the 3 over here. Z equals 1. Kind of a boring answer, 1, 1, 1. But keep in mind that we're supposed to write our answers in order triple. X first, y second, z third. 1, 1, 1. And that's the answer. Okay. And that right there is not just a lot of work to be shown. But again, I did cut that little corner there. These were pretty nice because we didn't have to do any multiplication here to make it happen, right? It was all ready to go as is. Now, going back to this substitution idea, again, my goal anytime I do a substitution or elimination is to get rid of a letter in the problem, so to go from 3 variables into 2 variables. So I can solve this for x, this for z, this for y, this for z, or this for z easily. A coefficient of 1 is the key. All right? So if I did a substitution technique, let's say I take this equation here and solve for z. I'm going to move the z over there, right? So 2x stays where it is, y stays where it is, and z moves across. So z is equal to 2x minus y. If I do substitution and z is going to equal 2x minus y, I'm going to put 2x minus y here and here to account for that. So the top equation becomes x plus 2y plus z, which is 2x minus y, equals 4. Combined like terms, that gets me 3x plus y equals 4. And if I take 2x plus y and put it in place of the other equation, let me go with a different color here, I'm going to get 2x minus 2y plus z equals 1, but z is going to be 2x minus y. 2x minus y. 2x plus 2x is 4x. Negative 2y minus y is negative 3y. And equals 1. You got me to the same place, right? Again, what do you think is easier? That's what it boils down to. I personally like elimination on these, but if you like substitution because that's what you've been doing, that's what you're comfortable with, that's how substitution looks. Getting to here I think is a little bit more complicated, but you get to the same place and then everything from that point looks the same.